Nearly all projects in Tier Portal will make use of a timer of some sort, and you can find timers in the Instructions tab, Basic Instructions, Timer Operations, and you have different types of timers and also supporting instructions in this folder here. So now we're going to use a TON or a ton timer, which is the most common type of timer, and this is a on delay timer. So let me drop that in and create an instance. I'm working in OB1, so single instance is the only option available. And I'm just going to call this timer 1. And Tier Portal drops in the interface for the function block. And on it, we have a Boolean input, a PT input, which is a time input. And we have a Boolean output, and also a ET for elapsed time, and that's also a time output. Effectively, what we have here is if the input is true, or the preceding logic is true, then the timer starts. It will run until it meets its PT requirements, at which point it will then turn Q on and output a true. And we can also see the elapsed time here, and we could assign that to a variable if we wanted to, but a lot of people don't unless you're using it somewhere else, displaying it on a HMI or SCADA, or using it programmatically to do something when a certain amount of time has elapsed. So let's set this one up. I'm going to put on the front of here bools 1, and I'm going to give it a time of T for time, hash 10 seconds. So this is a time constant. I could also write in here 10,000, which is 10,000 milliseconds, and you'll see that it changes it to 10 seconds. If I wrote 12,000, it changes it to 12 seconds. Personally, I like to work with the actual time value rather than typing in milliseconds, but you can work in both, but it will always display as a time in actual time format. If you're writing constants, that is. So let's get this downloaded to the PLC. So at this point, everything looks how we'd expect it to look, which is we have an input and some logic before the input to make sure that it doesn't just run. And we have a function block using its own data. And when we set this to true, we expect the timer to run. So if I set this to true, the timer doesn't run. And this is something that there is a lot of questions about for new starters, beginners looking at Tier Portal, working with PLCs, simulated PLCs and things like that, coming up against a timer and on their first try, not understanding why this doesn't work. And unfortunately, the truth is it is working. It's doing what it's supposed to do. But this is an issue with how Tier Portal shows a timer. Because we don't have anything on the output here, the way timers work in Tier Portal is this is an asynchronous function. So just because it's here in your logic does not necessarily mean it's being called at that time. And effectively, there's a quirk that if we don't have a coil or somewhere to write that output to, then Tier Portal acts like it's not being used, and therefore it doesn't update anything to say I need to be read. So it doesn't necessarily mean that the information is not true, but it does mean that it's not being used, therefore I won't update it. For example, if I come down to this line here and I add in timer 1 Q, and I get that to set bools V2, and I don't do anything else, and then download to the PLC. What we see now is that the timer is actually complete and B2 is set. I haven't changed anything to do with the timer. It's still been on since B1's been on, but it's a really frustrating thing that Siemens haven't fixed throughout the sort of life cycle of Tier Portal, and it does catch people out, and it does make you think that something's wrong. So what I would suggest doing is not doing this with your timer. Don't use the data directly, and you should really write to a coil. So I'm going to write this to timer 1 done. I'm going to declare this as a temporary. I have to because we're in OB1. And then I'm going to move that down to there. And I will load that into the PLC. And we have exactly the same result. You know, it's showing the correct thing, but it's much more clear that this is the link that we're doing. And I wanted to demonstrate that straight out of the gates because it will be the first thing that somebody comes up against and says, mine doesn't work, but I'm doing the same thing that you're doing. So I wanted to show that. So yeah, look out for that one. Okay, so let's get back to the actual timer. So what we have here is a TON, which is a on delay. When I set B1 to true, we should now see that the timer times. So modify to 1. We can see that this is the internal timer, the elapsed time. So you won't see anything on here unless you have a variable there, but that is what this would be. When it gets to 10 seconds, the output comes on and the timer starts, and the timer 1 done is set to true, which then sets B2. As soon as I turn this off, the output goes off and the elapsed time resets. And that is a on delay. So a TON is a on delay, timer on delay. Just like other functions or function blocks that are provided by Siemens and the instructions, if I double click here, I can change this to a TOF, which is a timer off delay. Notice that I don't have to change anything. I don't have to change my instance data. It's not saying that needs to be updated. I don't have to change anything about how I'm organizing my interface for this function block or anything like that. If I go ahead and download to the PLC, we can see that this is off and our output is off. When I turn B1 on, immediately the timer comes on this time. So there's absolutely no delay. As soon as this went true, the output of this was true. But when I turn this off, we now have the 10-second delay before this turns off. And if I turn this back on, you see that resets. That's something I didn't show you with the TON, but it works the same way with the TON timer as well, that if you turn it off before the timer completes, then it resets. And if I turn it back to, if I turn it back to off, we'll let it complete this time. We will see that it drops out and turns the timer 1 done off. So those are your two different on and off delays. And then we also have a TP, which is time period timer. And again, notice that I've changed that, but I don't need to change anything else. So let's get that downloaded. And this one works slightly differently. If I set this to true, it starts timing. But if I set this back to false, it continues to time. And if I set it back to true again, it makes no difference. For the time period in which the PT timer is, it will be true. And then notice that it turned off at the end, even though the input is still true. So it's only on for the time period. That's it. Then what it needs to see is that the input goes to false. That reset the timer. And then it must come back to true. And then it can go false again and stay false, but the output will remain true. And what we'll see this time is as soon as it gets to 10 seconds, it will reset, which it did. So that's a time period timer. I think some PLCs call them time pulses. Oh, it might be, yeah, Siemens that call it time pulse. Sorry, it's not time period, but I like to think of it as a period of time. It's not really a pulse because it might not run again, and well, it won't run again until B1 is on. So it's more of a time period, but very, very useful for sort of fire and forget timers where B1 might pulse for one scan and you want something to happen or not happen for a period of time. So finally, we have a TONR, which is a cumulative timer. If I drop this in, again, I have to create an instance for this. I'm going to call this timer 2. And you'll notice that this has a slightly different interface. So if I try to drop down on this one, I can't because it doesn't use the same interface as all the other timers. We have exactly the same interface, except for we also have this R, which is for reset. So I'm going to go ahead and set up what I had before. So here I have timer 2, which is a retentive timer or a cumulative timer. And what this does is if B1 goes true, it will act as a normal on delay. But when B1 goes false again, it will not reset. So let's have a look at that. We're timing. If I turn this off again, notice that the elapsed time value stays as 3.6 seconds. We're not resetting just because B1's gone false. If I set it to true again, it continues from where it was. Set it to false again, and it pauses again. And if B3 then goes true, it resets. And if B1 goes true whilst the reset is true, notice that the reset wins. So the timer won't run if the reset is active. When the reset goes false, the timer starts, and we'll let it go through to completion. Because one of the things that some people might sort of get wrong with a retentive timer is if B1 goes false now, what the output might be. So the output remains true. Now that's not immediately obvious, but because it's a retentive timer, which remembers the ET value, it's the ET value being greater than or equal to the PT value, which is causing the Q to be true. And just because B1 is off doesn't take away from the fact that this does equal this. So the output should be on. The only way to reset this now is for B3 to be set to true. And that's it. So very useful timer for accumulative sort of processes where you want to time something as an event happens, but have a limit to say it can only happen for so long inside a wider time period. So the last thing that I want to touch on with timers is another quirk of Siemens that is not immediately obvious, but in fact there's two, and it's all to do with this PT value here. Now, the first thing is right now we can see that I have 0 milliseconds set as the PT. If I turn this on, sometimes you end up in the situation where the output doesn't output because it doesn't like having a value of 0. I'm not quite sure why Siemens default time value is 0. It should be something like 10 milliseconds, but I can't see a reason why you'd ever have a timer set at 0. But in this case, it does appear to be working correctly, but I have seen times where the output doesn't turn on because the PT is set to 0. Or you end up with a situation where the output is on when the timer isn't running. And perhaps they fixed this in later versions, but it certainly used to be an issue at the beginning, and it's something that I would try to avoid. And the other issue is if I set this to a large value such as 1 hour, and then turn this timer on, and then change this value back to something like 15 seconds, what I have seen is this will continue to run until the hour that it was originally set to, and won't update past that. So this is what we're seeing now. You'll notice that this is set to 15 seconds, but this will continue on to an hour until it sets its output. And again, if I change this again to 10 seconds, nothing happens. And this is quite a frustrating issue with how Siemens interpret the instruction or the IEC requirements for delay timers. And effectively what they're saying is when you turn the timer on the input, you should move the value coming into PT into the PT coil and start running the timer. And you don't look at the PT value again until the timer completes. In a practical world, such as an operator going to a control panel and changing the duration of an event that has already started running, that's impractical. We can't stop the timer and restart the timer because somebody's changed the value. So there is a workaround for this, and it's something that I do all the time, which is you need to use a special coil called a PT coil, and you'll find it here, which is load time duration. And if you drop that in front of your in, and what you need to do is give timer 1 at the top, and then your new value that you're loading in, which would be the same as what you're putting on the front of your PT coil. Download that to the controller, and you'll see straight away that the timer completes. But I will run through the demonstration again. So the time is completed at 10 seconds now. And what this coil does is it says, I'm targeting timer 1 with this new value in here, which is T1, 10 seconds. And for the whole time that this coil is true, it will constantly load the new value on the front of this PT into the inner PT value that's stored inside this data block here. If that doesn't make sense, then hopefully this demonstration will make sense. So I'm going to modify that to a 0 again. And this time I'm going to set this to an hour. Let's turn this on. And we'll let this run past 10 seconds, and then I'll set it to 10 seconds, and you'll see that it will immediately complete. Whoops. Set that to T, 10 seconds, and the timer completes. If that coil wasn't there, then that wouldn't happen, and you would have to wait until either the input went off or the timer completed in order for it to load the new PT value. And yeah, something that, again, wanted to mention because it's very, very easy to be caught out. And also it's quite an easy thing to miss during something like testing, where you're testing your timer. It does do everything you expect it to do, and changing the PT value during running is not necessarily something that might make it to a test list. It's not something that you might immediately think of testing. So yeah, I wanted to highlight that one because that's caught me out far too many times. What I've actually done is wrapped this section here in a function block so that the PT coil is always included in the function block that I call. Below this video, I will link an article that talks about wrapping these functions. It's from another area of the website. And yeah, I would have a look through that because I believe it talks about this problem as well. But as far as timers go, that's pretty much everything you need to know on a basic level. And yeah, have a play with them because there's lots of different ways that you can use them, including the ET value here with the comparators that we've learned in this section. So yeah, have a little play.